Let us solve questions related to calculus. So these were the questions given to us in the sample question paper by IISc Bangalore from calculus section. So they gave this limit and they're asking what is the value of it. So let's apply the limit and see whether this comes in a indeterminate form or not. If you apply the limit, so what we get is limit x tends to 2. So when you apply, you get root 2 minus root 2 by 2 minus 2. So obviously this is 0 by 0 form. Now whenever you have 0 by 0 form, we apply L'Hospital rule. So what L'Hospital rule says is, take the derivative of the numerator, derivative of the denominator separately, apply the limit. So let's apply the derivative of the numerator. The derivative of the numerator is 1 by 2 root x minus 0 by, what's the derivative of the denominator? It is 1 minus 0. So you apply the limit now. Limit x tends to. So if you apply the limit, since this denominator is a constant one, no need to worry, this is 0. Just apply the limit as x tends to 2, what happens? So you get the answer as 1 by 2 root 2. Such a simple question, 1 by 2 root 2, which is nothing but option C. So what I have done is just applied L'Hospital rule, I got the answer. The function f of x equal to 1 plus x square has dash, and various options are given. So what options are there? Minimum at so and so point, maximum at so and so point, no saddle point at minus 0.5, none of the above. So let us analyze this. Whenever you get a question like this, so what we do is, we'll find the first derivative. What's the first derivative? The derivative of 1 is 0 and then plus 1 plus 2x. Next, equate this first derivative to 0. So 1 plus 2x equal to 0. So what is the value of x? It is minus 1 by 2. X equal to minus 1 by 2 is the stationary point. Now what we usually do is, you find the sign of the second derivative here. So what is f double dash of x? Here already we have the first derivative. So what's a second? If you want the second derivative, again perform differentiation. So it's 0 plus 2. So the second derivative is clearly 2. You substitute this point f double dash of minus 0.5, because 1 by minus 1 by 2 is minus 0.5. So even at this point, the value is 2 clearly, which is greater than 0. So if your second derivative at the stationary point is greater than 0, so that leads to what? A minimum. So this function has a minimum at x equal to minus 0.5, minimum. So yes, option A is right, minimum. We have a minimum at x equal to minus 0.5. Let's proceed. So clearly they have specified a concept called optimization in your syllabus. So optimization, that too they have clearly mentioned, optimization involving single variable. So I can say that this question comes under optimization. So optimization is all about the maxima and minima. There is a question again, I'll show you after some time. There is another question on optimization. Okay, so we will discuss this. They gave a function, very complicated function, like f of x equal to 1 plus 2x plus 3x square plus so on, 2026 into x power 2025, a very complicated function. Which of the following statement is true? Now you will apply the usual logic, like what is f dash of x? Equate the f dash of x to 0, and then find the stationary points, substitute the stationary points into the second derivative. But you cannot do all those calculations here. I'll tell you why you cannot do and what should be the efficient way in the exam. Since it's a competitive exam, you will face a lot of difficulties while solving this question. What kind of difficulties? So have a look at this. What is f dash? Okay, the first derivative. So the derivative of 1 is 0, the derivative of 2x is 2, plus the derivative of 3x square is 3 into 2, okay, 3 into 2 into x, plus what would be the next term? It would be 4x cube, na? So its derivative would be 4 into 3 into x square, plus so on, and then you will have 20 26 into 2025 x power 2024. This is how the first derivative looks like. If you try to equate this to 0 and then if you try to find the stationary point, it's almost impossible to get the stationary points because it's a polynomial of degree 2024. It's a polynomial of degree 2024. Finding roots of a polynomial of 2024 is impossible for us. So this is not the right way. Then what is the right way? The right way is observe the given function. Observe the given function. Look at the pattern. Now what you have is an odd power here. What you have is an odd power. 2025 is an odd power. Now you try to take another function similar with the similar coefficients with one odd power and you analyze. Whatever results you get for that polynomial, the same results will also obey for this because pattern is important. Whatever results apply for a similar polynomial with the similar coefficients, you can also extend for this higher polynomial as well. So let me show you what I am talking about. Let's take a polynomial in this form with a similar coefficient pattern, something like 1 plus 2x plus 3x square plus 4x cube. Here important thing is it a third degree polynomial? Yes, third degree polynomial, odd degree polynomial. That is very important. In the question also they gave 2025 which is a odd number. So odd degree polynomial, the highest degree is a odd number there. Here also it's a odd number. That is very, very important. If you take any even degree polynomial, then everything will change and you'll get wrong answers. So what next? Let's find g dash of x, which is 2 plus 6x plus 12x square. Okay. Then let's equate this to 0. So 2 plus 6x plus 12x square equal to 0. So 2 is out, then 1 plus 3x plus 6x square equal to 0. This is what is left. Now you need to find the roots. Okay, how do you find the roots? So if you find the roots, you get the stationary points. So let me find the roots. The roots formula is minus b, which is minus 3 plus or minus 3 square minus 4 into 1 into 6 whole divided by 2. So what are the roots? Minus 3 plus or minus, this is 9 and that is 24. So if I remove 4, 20, if I remove 5, 15. Okay. So 9 minus 24 is 15 or minus 15, let's say. So this is minus 15. So because of this minus, students, because of the minus, the roots, whatever roots you are going to get, they are not real numbers. So they are complex. So let's write this comment, not real. So what are they? They are complex. Now no need to analyze when you have got complex roots. So we need the stationary points to be real numbers. But you have got the complex roots. So what next? Let me check. So I cannot comment anything about the maxima minima. Let me check about the saddle point. So what is the procedure for saddle point, students? For saddle point. Now see here, there are no real values. So I can say maxima minima does not exist for here. Let me check for the saddle point. Let me check for saddle point. So how do you check for saddle point, students? You will first find the second derivative. So you have taken it as g. So let us find g double dash of x. So what's the second derivative? We have the first derivative here. So the derivative of 2 is 0. Then here it is 6. And then here it is 24x. Equate the second derivative to 0. That is 6 plus 24x equal to 0. You get the value of x. The value of x is minus 1 by 4. Now, how do you decide whether it is a inflection point or not? So for that, so how much is this? This is minus 0.25, students. Try to find what is g double dash of minus. So take a point to the left of this and as well as to the right of this. So let's take some points like this. You find its sign. You take another point like this. So how did I take these points? You can mark, this is the number line, students. This is minus 0.25. This is minus 0.26. This is minus 0.24. Take a point to the left as well as right of minus 0.25 and then check their signs. You will see that because you have to substitute here, you can use your calculator. You will see that the second derivative is changing the sign. Second derivative is changing the sign. So what I mean by that is, so if you use your calculator, you might get this as a negative value and you might get this as a positive value, okay, or vice versa. But you will definitely get these values of opposite sign. Which sign? Opposite sign. So I'll write like this. Whatever values you get it as opposite sign. You can use your calculators and check it opposite. Finally, what's the conclusion? See here, I've taken a simple polynomial, a third degree polynomial with similar coefficients. We found that no stationary points, no real stationary points. And then I checked for the inflection point. For that, I equated the second derivative to 0. And I have seen that at minus 0.25, the second derivative is changing the sign. Therefore, this is clearly a inflection point. So now what's the conclusion? At inflection point, we have neither maxima nor minima. You can pick the appropriate option. So f of x has global minimum. We said no. No maxima, no minima, we said. And he says f of x has global maximum. No. F of x does not have a global minimum. Yes. So this fits into the correct answer. So we said no maxima, no minima. Whatever point, we have no real stationary points, and in fact at minus 0.25 we have a inflection point. So f of x does not have a global minima is a correct statement in this particular problem. Students, you might be thinking, sir, this is the polynomial you are supposed to analyze, but you have taken a simple polynomial like this. Yes. Whatever analysis works here, the same thing can be extended to this as well. That's the pattern. Now, you cannot take an even degree polynomial and then apply the same results to the given question. Try to take with an odd polynomial. Maybe you can try with, you can extend this. This is 4x cubed and then you say plus 5x power 4 plus 6x power 5. You can take a fifth degree polynomial. Again, you will get the same results. But that fifth degree polynomial is again very difficult to analyze. So, it's a very good way of analyzing in a competitive exam. So, the answer is f of x does not have a global minimum. Let's go to the next one. You can see that there are 3 questions. So this is one, this is another, and this is also under this optimization where maxima minima technique is needed. So let us look at this question. He says a company manufactures a product at a rate of P units per day. So a company produces P units in a day. That's what is given, P units. For example, you are talking about mobile phone manufacturing. So it is going to produce P cell phones in a day or P units in a day. The cost per unit in rupees is given by an equation that is C equal to 50 plus 0.1 P plus 9000 by P. The selling price per unit is 300 rupees. So after manufacturing it, they are selling it at 300 rupees per unit. The production level minimizing the cost per unit and the total profit respectively are. Various options are given. There is a small ambiguity in this question. After a thorough analysis, we found what is the issue with this. So as we progress with the solution, I'll explain you what should have been given in the question. Okay, let's proceed with this question. It says they're manufacturing P units. That's okay. And then say the cost per unit. So what is the cost that is incurred by the company? So it is given by equation which is C equal to 50 plus 0.1 P plus 9000 by P. The selling price per unit is 300 rupees. The production level minimizing the cost per unit. So let's write this again. What is C? It is 50 plus 0.1 P plus 9,000 by P. This is what is the cost per unit. Now, how many units I have to produce so that I can minimize the cost per unit? How many, let's say if you are talking about mobile phones, how many mobile phones have to produce or manufacture in a day so that the cost per unit is minimum? So you have to find that P which is going to minimize this C, that is cost per unit. It is so simple. You can say that C is a function of P. You can apply the maxima minima concept here. So according to maxima minima, clearly C is a function of P. So you perform this dC by dP. Find the derivative of this. So this is 0 plus this is 0.1, and then what's the derivative of 1 by x? Minus 1 by x square. So 1 by P derivative is minus 1 by P square, that is minus 9,000 by P square. What next? We usually equate this to 0 to find the stationary points. So let us equate this to 0. If you equate this to 0, what do we get? 0.1 minus 9,000 by P square is equal to 0. So you can rearrange. This is 9,000 by P square. You get P square equal to 9,000 by 0.1, which is 90,000. So P square equal to 90,000. So what's the value of P? If you take the square root, you get plus or minus, na? But minus anyway is meaningless here. So the value of P is 300. If you can produce 300 units, then this C, cost per unit, gets minimum. Or for what value of P is the value C minimum? The answer is 300. You have to produce 300 units in a day to minimize this C. Do we have such options? Yes, 300 is there, 300 is there. You can eliminate this, you can eliminate this. This is the first part of the question. So in the first part, they are asking how many units you need to produce so that the cost per unit is minimum. So the answer is 300. You might also ask, sir, you have just calculated the stationary point. You should also check the second derivative. Yes, I will check the second derivative, not a big thing. So let's find it in the next page, because we are not sure unless the second derivative sign. Okay, so let's find the second derivative. What is d square c by dp square? So what's the derivative of this point 1? It is 0. What's the derivative of 1 by p square? So 1 by x square derivative is minus 2 by x cube. So minus 9,000. 1 by p square derivative is minus 2 by p cube. So what is this final value? It is 18,000 by p cube. If you substitute 300, so let's say at p equal to 300, so what is the second derivative value? So we don't need exactly how much is this. Is it positive or not? Clearly it is positive, because 18,000 by 300 cube is clearly greater than 0. When the second derivative is greater than 0, obviously at that stationary point we have a minimum. There is no ambiguity about that. So even have verified that, yes, 300 is the right answer. The next thing is, he's also talking about the total profit. He's talking about total profit. So first of all, let's look at what is the total profit. So total profit, let us indicate this with capital T, because P is already used. So profit P doesn't work because P, the variable P, is already used in the problem. So I'm just indicating with another letter called T. So what is the total profit? The total profit is nothing but the total selling price minus whatever cost it has incurred to produce those units. So what is the total selling price? Each unit is sold at a price of 300 rupees. So it is 300 into how many units? P units have been produced in a day. So this is the selling price. Now what was your cost to produce this? the cost for 1 unit. So we need to subtract, then only you get the profit. Na? So it is 50 plus 0.1 P and then plus 9000 by P. This is cost per unit. So how many such units have been produced? P units have been produced. So this is the revenue that we have got after selling. This is the cost for manufacturing it. If you definitely take the difference, definitely we get the profit, right? So this is the function now. So this is 300p, like multiply, this is 50p. So there is a minus sign, you have to be a little careful, minus 0.1, it's p square, minus, so pp cancels, you have this minus 9000. Let us denote this with capital T, the total profit. You can further simplify the total profit like this. It is 250p and then minus 0.1 p square and minus 9000. So now we need to find, so what is the value of p which maximizes our profit? So obviously we talk about maximizing the profit, na? So whether it is maximizing or minimizing, this maxima minima concept, it says first find the first derivative, get the stationary points, observe the second derivative value at those stationary points. So let us find the derivative. Let us find the derivative here. So what's the derivative? dt by dp, it is 250 minus, it is 0.2 into p, because p square derivative is 2p, right? So 2 gets multiplied. You have to equate this to 0. If you equate this to 0, what happens? 250 equal to 0.2 into p. What is the value of p? It is 250 by 0.2. So after cancellation, you get it as 1250. So what it says, so we got a stationary point like p equal to 1250. Let us find the second derivative to confirm this, that the profit is maximum whenever p is 1250. So how do you do that? Find the second derivative. So it is d square capital T by dp square. So what's the second derivative, students? So here you have the first derivative, take another differentiation. So this is 0 minus 0.2 into 1. So no need to write, just minus 0.2. So minus 0.2. So even at p equal to 1250, what is the sign? D square t by dp square sign. It is still minus 0.2, which is less than 0. So at this stationary point, we have the second derivative negative. That means the function t maximizes at p equal to 1250. So if you want to maximize the total profit, then you have to produce 1250 units in a day. So that's what is the answer. Do we have any options like that? So cost per unit. So minimizing the cost per unit, the value of p is 300. If you want to maximize the profit, then it is 1250, which is nothing but option A. So here there is one kind of ambiguity. Is that production level minimizing the cost per unit, and they should have mentioned the production level maximizing the total profit. So that sentence is missing. So only after analyzing the question this way, I figured out that okay, they are also asking you to find the value of p for which the total profit is a maximum value. So after examining these options and after analyzing this way, I found okay, this is the question. So first we have to see what is the value of p which minimizes c. That's the first question. The second question is what is the value of p? What is the value of p which maximizes the total profit? And that is 1250. So I hope you have understood this question. Let's go to the next one. So here they say the value of the real variable x which is greater than or equal to 0, which maximizes the function x power e into e power minus x is. So they want to know, so what is the value of x for which the function is becoming maximum? See how many questions from optimization or maximum minimum? 1, 2, 3, 4 questions they have given from optimization, or we can also call maxima and minima. So your highest priority should be this topic. Let us solve this question. So what do they say? They give a function, they are asking for what value of x it is maximum. So simple. So let us write what is f of x here. It is x power e into e power minus x. So as usual, find the first derivative, find the stationary points, find the second derivative, substitute the stationary point of the second derivative. Based on the sign, you can now conclude. So what is f dash? Since we have x here, you need to use product rule. So I'll keep this quantity as it is. Then what's the derivative of this? The derivative of this is minus e power minus x. Okay, because e power minus x derivative is e power minus x derivative is minus 1, that's what is written, plus you can keep this as it is, that is e power minus x as it is. What is the derivative of x power n? Nx power n minus 1 that is e x power e minus 1. What next? We equate this to 0 to find the stationary points. So let us equate. So before that, do you have anything common here? Yes, there is common. So x power e into e power minus x is common. What is left is minus 1 here. What is left here is plus e power minus x came out. X power e also comes out. Then e by x is left over. You can equate this to 0. So when you equate, obviously you can equate this part to 0 because this cannot be 0. X power e cannot be 0. E power minus x also cannot be 0. Suppose you want to make this e power minus x 0, then you have to substitute x as infinity. So which we don't want. X power e is also not 0. So you can leave this, you focus on this. If you equate this to 0, then you get certain value. Okay. So what is that? This implies you can equate like this: minus 1 plus e by x equal to 0, minus 1 equal to minus e by x. This cancels. The value of x is e. So this is the stationary point. Obviously e is greater than 0 as well, because they want a x which is greater than 0 to satisfy this. Yes. But do we really have the maximum at x equal to e? How do you know that? So you can confirm that by finding the second derivative. So let us find the second derivative, students. So before that, what is the first derivative? Let's write it here. The first derivative was like this: x power e power minus x into minus 1 plus e by x. This was the first derivative. Let's find the second derivative. So what is f double dash of x? You take the derivative of this, keep this as it is, x power e power minus x. Find the derivative of this, which is 0 minus e by x square. Next, plus you keep this as it is, that is minus 1 plus e by x, and then find the derivative of this. But this is nothing but the f of x. This is nothing but f of x, students, whose derivative is f dash, which we already know. Okay, so you can, just for simplicity purpose, you can write it like this. So what we want is, we want the value of the second derivative at x equal to e. You can substitute. You might ask, sir, why do you not take in the derivative? You can take it. We have already taken the derivative here. Look, the derivative of this is calculated like this. So don't worry, just wait for some time. You will see some simple things. Substitute this. So this is like what? This is like e power e power minus e into minus e by e square, and then plus minus 1 plus e by e, and then f dash of e. E by e is 1, and then there is a minus 1. This complete term vanishes, it becomes 0. E power e into e power minus e is 1. e by e square is 1 by e, and then there is a minus. So finally we get minus 1 by e. Clearly this is less than 0. This term has vanished because after substituting e, it is giving you 0. What is the second derivative value at x equal to e? It is minus 1 by e, which is negative. Whenever the second derivative is negative at that stationary point, you can conclude that at x equal to e, the function f of x reaches the maximum value. The function f of x reaches the maximum value. So where does the function reach the maximum value? It reaches at a value called x equal to e, which is how much? 2.718 approximately. This is up to 2 decimals. Okay. So since this third decimal is 8, you can say it is 2.72. This is the answer for the question.